So let's get to this. Don't forget to sign in on that piece of paper right there, okay? How's that? All right, so now, what we're doing today is we're going to talk about the expected value, the variance and standard deviation expected value. What's different about this week compared to last week is last week we just had 6 or 8 numbers, okay? We only had 6 or 8 numbers. But this week we have numbers with weights, percentages with weights, right? No, it's only I signed everyone else in except for those who just walked in. I didn't get those last 2 signed in. I signed everyone else in already because I knew you were here and I took the picture. You guys got to sign in though because I didn't get them signed in on. So quickly sign in real quick, okay? All right. All right. So now, always start out the week with the instructions. So let's go with the instructions. We're going to see what to do this week. We got 3 different things going on here. The number line assignment, the written assignment, the Excel assignment. There's our 3 parts, okay? We talked a lot about the number line assignment last lecture on Tuesday. Do we have a quiz? Do we have a quiz in 5 days? Is that for sure? Is it right here? Is this where it's happening? Okay, let's make sure. All right. In the number line, when you go to do the number line exercise, it was all about you putting the bell curve together with calculating a true Z statistic. Remember that formula right here? I'll highlight it right there. X, whatever you're being asked to find the probability of, minus the mean, then divide by the standard deviation, and that will be your Z. Then you're gonna look up Z on the Z chart. You gotta follow these directions because you gotta also make sure you put which Z chart you're using, the positive or the negative. Then you put what you found on the Z chart. But if the question's saying some number or more, then don't forget you got that extra step where you gotta subtract from 1 to find the opposite of what you just looked up on the Z chart. Real quick, let's see if this is a more than or less than. See if you have to do that extra step. This question says, let's say the average number of apples in each cart. Don't forget to sign in. If you just walked in, sign in over there. I got everyone else signed in, but those who just walked in. Let's say the average number of apples in each cart is equal to 122.4 with a standard deviation of 15.6. All right? What is the probability, if we were to count the apples in the next cart, that there would be 130 apples or less? Okay, there's the question. My question to you is, when you're calculating this and you're finding your Z and you go to your Z chart and you looked it up, do you have to do the extra last step where you subtract from 1? Yes or no?
No.
Because it says less than, it's going to the left. Exactly, you don't have to do that extra step. But if that said or more, what was it? It's 130 apples or more than 130 apples or something like that, you have to do that extra step. You look it up on the Z chart and then you subtract it from 1 or change it to a percent and subtract from 100%, whichever way you do it. But you got that extra step if it was a more than. So you got it. There's your number line part of your homework. Again, I just talked about the end of it, but you got to draw the number line. I think it says shade. Are you shading? Yeah, shade the bell curve from 130 to the left when you put your numbers on there, and so on and so on. Next, let's go back to the instructions. Written assignment is next, okay? It says open this assignment, so we'll go there. Quick reminder, I want to make sure everybody realizes this for the quiz on, when's the quiz, this Saturday? Tuesday, thank you. I'm the only one who's going to be here Saturday, probably, right? Quick reminder, you need to download the PowerPoints. Don't just open them up and say, oh, they're in my RAM memory now, I'm going to use them. If you open them on Canvas, I've heard a bunch of people say you can't see the equations. You don't even realize that the equation's not there because you didn't know that it was supposed to be there. So download those PowerPoints when you get to the classroom before the quiz, because when you open them then after they're downloaded, you see all the equations that I've been showing up on the screen. So I want to make sure we realize that. If you're saying, gosh, it seems like this slide is missing something, it could be because you tried to open it in Canvas and some of the things aren't showing up for some reason. Probably because it's such an old PowerPoint. It's the only thing I can think of why it's not working in Canvas.
Question, so the quiz covers everything that we're doing through today.
That's right. Anything from today backwards, it could be on the quiz. Nothing after today will be on the quiz.
Okay, so what we're learning today,
what we're learning today could be on the quiz. You know, today is the hardest of anything we've learned so far. this one right here, binomial probability. A lot of people find that hard. Matter of fact, here's the formula right here. I wanted to put it right there. I want you to just stare at it all class long so you can see it. Odds of that being on your quiz are like 99.9%. I mean, I'd have to drink a lot this weekend and not put that on the quiz. And I stopped drinking a couple years ago, so that's gonna be tough. I'll just start my car and let it run with the door open, garage shut. Maybe that's the only way I can keep that off the quiz.
Z chart, is it gonna be on, like, are you gonna give us a sheet of it, or do we have to download it?
The quiz? Oh, I'm gonna hand the quiz to you, yeah.
Oh, the Z chart.
Yeah, now that, oh, the Z chart? No, download the Z chart. Download it off of Canvas. Everything I post on Canvas, you wanna download before the quiz starts, everything. Yeah, we're on Z, they're right there on week 3, towards the bottom. I moved the camera just to see if I could make the video a little better. I don't know if anybody, oh, hey, don't forget to sign in. Just walked in, don't forget to sign in on the table. I got everyone else, but those who came in late, I didn't get, so sign in. All right. See, this is only gonna work once, because after this, nobody's gonna sign in and watch it late, so you say it's the trick, right? All right. Now, the written part of the assignment, let's go there. Here it is, there's 4 parts to the written assignment. 1, 2, 3, 4. The first part is calculating the expected value, which you're gonna learn today. This is, look at, there's only 3 pieces of data there. And this is almost just like last week's homework, except now you have weights. And for this to be, and I'm not gonna trick you on a quiz, for this to be a true problem, those weights must add up to 1.0 or 100%, 1.0. So, as you can see, they add up to 1.0, and they will on the quiz if this question's on there. But I just wanna let you know, the difference between what you're learning this week and last week is, last week we had like 8 pieces of data. You had to find the variance and the standard deviation, the mean, the variance, standard deviation. This week, you have only 3 pieces of data, but the difference is you have weights with them. So the mean, when you have weights, is called the expected value. So this week, you're finding the expected value, the variance, and the standard deviation, just like last week, but you're using weights this week. So there's, I don't want you to get confused. Variance and standard deviation with the sample data, and then there's variance and standard deviation with weighted sample data. And that's what today is, weighted sample data. So very similar, but make sure you know the difference. That's the #1 mistake, is I'm asking for the variance and standard deviation on the quiz, and someone accidentally doesn't realize there's weights there, and they do it with just data, the way we did it last week. Where this week, you gotta say, oh, there's weights, and there's a little bit of change to how you calculate it. So there's the first problem. The second problem is just giving me probabilities from a probability table. This is data with weights right here, actually. They add up to 100% also. But the questions are you just how you read the data off this table and show me which numbers you're using to add up. Which numbers for each question, A, B, and C. There's 3 of them there. You gotta tell me which numbers you're using to find the answer.
Professor?
Yeah.
She just has a question.
Yeah. I gotta get away from this van so I can hear you.
Will the f of x or the weights always be provided?
Will the what always be provided?
The weighted other.
Yeah, there's weights with the data, they'll always be provided, yes. But don't forget, there's data last week where there's no weights at all, and I could be asking for the variance and standard deviation, so there would be no weights given. So that's the trick, but yeah, I'd always give you the data and the weights. Yeah, you're gonna find that the quiz is very much like the homework, as far as the wording of the problems and stuff. That's why, and open up the homework answers, you got it. If you have them all open and ready to go, you just gotta be able to identify, okay, this problem I'm reading on the quiz was just like week 2's homework problem, or week 3's probability questions, it's just like that one. Then you open up week 3's answers and you go, oh yeah, and then you attack it. But if you're somebody who goes, I have no idea where to find this help, I'm searching, you open every answer to every homework assignment, you open every PowerPoint, start going through every slide, time's up. And your grade's not gonna be that good, because you're gonna have to guess. When I say there's 1 minute left, you're gonna start guessing. And you must guess, because when I say there's 1 minute left, don't leave anything blank. That'd be crazy. I am so generous with partial credit. You've just tied my hands if there's nothing there to give partial credit for if you leave it blank. So when there's 1 minute up, if there's anything you have not answered, you go back and grab the numbers out of the problem and start adding, subtracting, multiplying, do something with those numbers, anything. to at least get a point or two. Don't leave anything blank. I can't emphasize that enough. You're just throwing points away. So there's the advice that just hopefully got you a couple points. All right, the second one is you answer those 3 questions. The third one is you're manually calculating the binomial probability for this question using this formula that you're learning today. Then the fourth one is just like the third one. Remember, you're gonna use the same information from the third problem, but you're gonna give me, this is like a quiz question. You're gonna write the Excel equation and the result, just like this was a quiz. When there's gonna be Excel questions on the quiz, but I'm not asking you to hand in a spreadsheet. This is just like a quiz question. Matter of fact, this is how Excel questions will be asked on the quizzes and the exam, just like this one, where you have to write out what you would type into a cell onto an Excel spreadsheet. Equals, max, whatever the equation is. And then give me the result. So meaning you're opening up Excel, putting the equation in, get the result, and you're writing that down also. So the equation and the result. Is this asking for the result? Do not answer this question by providing it on a spreadsheet. Handwrite your paper. Hang on with it. Write the Excel function equation just as if you're typing it into an Excel spreadsheet that uses the binomial probability Excel function to calculate the exact same result you just did manually above. Okay, this one's not even asking you to give me the result. But if this were a quiz question, I'm asking for the equation and result. So, you know, read the instructions and see what I'm asking for. In this one, I just want the equation.
Does this handwrite your answer?
Handwrite your what?
Answer.
Does it say handwrite your answer? Here, where? Handwrite your answer on paper. Yeah, but I'm still only asking for the equation, because I usually would say, saying write your Excel function equation, and then I'd say and the result usually is what I'd say right after that. So it's, in the first line it says write your Excel function equation, it's in bold, and then I'd put on the quiz I'd say and the result. Okay, so there's the written part of the assignment. Any questions? So it's an expected value question with variance and standard deviation. It's a probability question. It's a binomial manual question, and then a binomial Excel question, which we're learning today. Now, the Excel part of your homework. There's just 2 questions. Just 2 of them, and both of them are showing me that you can use the Excel function for binomial probability. So that's what both of those answers are gonna be. I want to tell you, this is not that hard, but it's kind of tricky. And so a very common mistake gets made on these when it comes to whether you should use either the word true or a 1, they mean the same thing, on the end of an Excel in the parentheses, or a 0. There's a 1 or a 0 for true or false, which I'll explain in just a little bit. So anyway, so there's only 2 problems on the Excel, and you hand in the spreadsheet just like you always do. So you have the number line, the written, and the Excel. Does everybody know what's due before Saturday? Before Saturday at 11 a.m., right? 11 a.m.? What?
11 p.m.
Oh, 11 p.m. Is there a Michigan game this Saturday?
Yes.
Home or away?
Home.
Home? 3 home games in a row?
4.
What time?
12 noon.
Sure?
Yep.
Okay, homework's due at 11 p.m. then. All right. Just making sure that there was time. That's all.
Some of us didn't even leave the stadium until like 12:30 last week, so we had to make sure we got our homework done before the game.
Well, the game didn't start so late.
9 o'clock.
Didn't start at 8?
No, it got backed up by an hour because of weather. It was the latest kick in Michigan Stadium history.
All right, you guys, you ready? You ready to learn this stuff? Let's go to chapter 5, PowerPoint slide 3. Refresh our memory just a little bit here. Discrete, continuous data. Remember the difference? Discrete data, how many? Continuous data, how much? All right, here's an example of discrete data. You're managing a TV, a place that's, let's say ABC warehouse type place. Are they down here in Detroit, ABC warehouse? Really? You do know of one? Okay, well, they sell a bunch of stuff. Not just, they sell appliances, they sell TVs, they sell electronics, all kinds of things. But let's say we're just looking at TVs, and you're the manager, and you went ahead and grabbed the last 200 normal days, not holidays or specials going on, because you want to predict the next 10 normal days, trying to figure out staffing for the TV section. So you're doing staffing for appliances, staffing for electronics, and you're figuring out how many you want to staff. You probably always want to have maybe 1 there if you think you're going to have low sales, maybe 2 or 3 in that area scheduled for all day, all the way, whatever hours you're open. So you're figuring out staffing. You go back the last 200 days to see how many TVs have been sold for each of the last 200 normal days. And we talked about this on Tuesday. There's only 0, 1, 2, 3, or 4 TVs have been sold. Never sold 5 TVs in any of those 200 days. So we went ahead and took the data now we just collected of how many TVs we sold over 200 regular business days. Don't forget to sign in right on the side, okay? Over 200 business days, I can't help but stop myself. I just can't help it. Hang on, I gotta get my mind back together here. It's only gonna work once, that's why it's so fun. All right. So out of the last 200 days, we gotta now take all that data and turn it into a frequency table. How many of each amount of TVs did we sell? So we can figure out then the probability of how many we could be selling in the future days, which would be probably the average amount we've sold. But there's some days we sold like 3 TVs, a whole bunch of days. But there's a whole bunch of, only a couple days where we sold 4. But there's a whole bunch of days we only sold 0. So let's take a look at how many of each day. So where's the countdown here? Hang on, look, there it is. There's all 200. How many TVs did we sell per day the most out of the last 200 days? How many has the most times? How many TVs has the most days that we've done? How many? 0 TVs. 0. So this is not a hard staffing problem. We may not need more than just 1 person maybe there. Look at, out of almost half, 80 out of 200 days, 80 divided by 200 is 0.40. So there, what kind of frequency table? We have a frequency table where it says number of days, but now that we're doing the math on this, what kind of table are we making? What kind of frequency table? Relative frequency. Relative frequency table, because we turned it into a decimal. 80 divided by 200, 50 divided by 200. And the least amount, I can't believe we've had more days we sold 4 instead of 3. That's shocking, actually. But the least amount's 3 TVs a day, and there was 10 out of the last 200. So there's a 5% chance that tomorrow we're gonna sell 3 TVs. There is a 40% chance we're selling 0 TVs tomorrow, based on the last 200 days. And believe it or not, after you've been in business for a long time, things this kind of is pretty close to probably what would happen unless there's some kind of economic change that's taken place compared to the last 200 days. And this gives you a good idea. So, but we want to know the average. So, go ahead and sign, don't forget to sign in, okay? We want to know the average amount of days. I can't help myself. This is going to be an awful video. I'm going to have to tape the next class. Awful video. To get the average though, you just don't add up 4 plus 3 plus 2 plus 1 plus 0 and divide by 5. That was last week. But this week we have weights involved. So we have to multiply the weights times each piece of data. 0 times 40%, 1 times 25%. And it looks like this. Wait, what happened? Did I pass it? Here we go. 0 times 40%, we're in the 3rd column now, is 0. 1 times 0.25, 25%, 0.25. 2 times 0.20, 0.40. And 3 times and 4 times, they're percentages, they're weights. The average amount of TVs we sold over the last 200 days was 1.2 TVs. So now you're managing, you're going, I know that I'm going to schedule the next 10 days. Everybody wants to know the schedule. And I know days, early mornings are a little slower than late afternoons and early evenings. So knowing that our average for the next 10 days is probably going to be 1 to 2 TVs a day, I'm going to work out the schedule this way. So we're weighted data, finding that mean. Okay, now let's take it a step farther.
We're gonna have to make a chart like that. Could we? Is it like a possibility?
Yeah, oh yeah. Yeah, you have to do it on your homework. Matter of fact, on your homework, I'm only giving you the X and the weights. It says on the homework, you now gotta find the expected value. You gotta do that 3rd column. That's the first part of that written homework assignment. So you gotta do those straight across and add them up. Now, once you have that expected value, which is now the mean for weighted, you're gonna do it just like you did last week. find the variance and the standard deviation, but use 1.2. Don't add up 4, 3, 2, 1, 0 and divide by 5 because there's 5 pieces of data there. No. Use, because we have the weight, you gotta use that 1.2, that expected value, that weighted mean. And now 0 minus 1.2, 1 minus 1.2, 2 minus 1.2, 3 minus 1.2, 4 minus 1.2. Remember that? The formula for variance, you had to subtract the mean from every number, and then the next step was to take those subtractions and do what with each one of them? Anybody remember? Can't hear you. Square them. I heard this direction. So let's take a look. 0, where's my, the column that's missing is the 1.2. No, so 0 minus 1.2, second column, negative 1.2. 1 minus 1.2, I would have added a column between x and the x minus the mean and put 1.2 all the way down 5 times. 1.2, 1.2, 1.2, just like we did last week. So then 2 minus 1.2 is the 0.8. There's the 0.8 right there. 3 minus 1.2, 1.8. 4 minus 1.2. Next step, square each one of these, just like we did last week. Negative 1.2 times negative 1.2. Don't forget, all of your squares will be positive. None of them should be negative. That's the whole reason we're squaring, is to get rid of the negatives. So negative 0.2 squared is positive 0.04. 0.8 squared, positive 0.64, so on, so on. Now, last week, we now add the squares. But no, when there's weights involved, you've got this extra step. Are you ready? You now have to take those squares and multiply them by the corresponding weights that you started with. This is the extra step. Let me say it again. Look at these weights, 40, 25, 20, 5, and 10. Let me go back to the original problem. They're the original weights that were given to us. Going all the way back. These are the original weights right there. This is what I'm giving to you. Oh, I see your question. Would I give you the weights, or you have to calculate the weights? Is what? No, I'm probably going to give you the weights. So I want to make sure you identify that it's a weighted data. Does that help? Okay. I didn't understand. So there's the weights, the same weights. So we're going to take each one of these squares now and multiply by their corresponding weights that were given to us at the beginning of the problem. So 1.44 times 40%, 0.40, 0.576. Now look, this is going 3 digits to the right. Now I know I always say, at least go 2 digits to the right of the decimal, but you know, and I'll give you that. I'll still say 2, but please try to go 3 if you can, but at least you have to go at least 2 digits to the right of the decimal, okay? But 576, now 0.04 times 0.25, 0.10, 0.64 times 0.20, and so on and so on. Now that you got past that extra step, because we have weighted data, now you add them up. There they are. You add them up. But you don't have to divide by n minus 1. Because we use those weights, it replaces dividing by n minus 1. So when we do that last column, we add them up, there's your variance. 1.66, that's the variance. All we have to do is add up that last column. We don't, now last week we would now divide by, well there was 1, 2, 3, 4, 5 different data, so we would divide by 5 minus 1, 4. But this week, instead, we multiplied the squares by the weights. All we gotta do now is add, no dividing. Just add that last column. There's your variance. So the amount of sales of TVs for each day over the last 200 days has a variance of 1.66, but that's kind of a big number. That's why we square root it to turn it into a standard deviation so it makes more sense. So instead, the standard deviation is 1.2884. We square rooted 1.66. That's where that number came from. Let me say it again because it doesn't show you there. We went from the variance to the standard deviation by square rooting the variance, and it doesn't show that. So I hope you got that. The square root of 1.66 equals 1.2884. Slide number 13. Slide number 13, standard deviation is the square root of the variance. Now that is how much each day's sales over the last 200 days have varied from the mean, the expected value of 1.2. It varies about 1.2884. All right, that is that you now have finished what you needed to know to do that first problem on the written part of your homework. It's asking you for the expected value, the variance and standard deviation of the weighted data, but there's only 3 pieces of data instead of 5. All right, next, any questions on this? Go ahead.
So since it's weighted, we don't have to put in the equation we did last week?
Right, you're using a different equation. Instead, you're doing an extra step where you're taking the middle, all those squares, 1.44, 1.04, and you multiply them times each weight. That's the difference. And so you don't have that division like last week at the end. So you have one way of doing it if I'm just giving you data, asking for the variance and standard deviation. And you have another way of doing it if I'm asking for the variance and standard deviation and I'm giving you data with weights. Two different ways. Don't forget to sign in right there. All right, where am I going here? Probability fit. Here we go, let me make it big. Okay. This is similar to the second problem on the written portion of the assignment, okay? And what's happening here is you're given some data, 0, 1, 2, 3, and you're given the relative frequencies. And notice the frequencies add up to 1.0, 100%. So we're going to question B. B says, now real quick, this is how many, this realtor sold, how many houses per month this realtor happened to have sold. And went back how many months? I don't see how many months they went back, but however many months they went back to look at for this realtor, there were 0 houses sold some of the months, there was 1 house sold, 2 houses, and, excuse me, some of the months, 3 houses sold. That's a good month, sell 3 houses in 1 month. My question for you is, what is the most common occurrence for this particular realtor as to how many he or she was selling in a month? How many? 1. Very good. Because it's the biggest percentage. 50% of the time, this realtor sold 1. So there's the biggest chance of how many next month? Probably 1. About a 50% chance. So now we'll go to B. What's the probability that this realtor does not sell any homes in a 1-month period? What's the probability in the next month that no homes will be sold? What number, how many numbers you gotta use off that chart first off to answer this question? How many numbers off that chart? I got the fan, so I can't hear you. You're gonna have to speak up, you guys.
2.
Only 1 number. Because there's only 1 number out of all those numbers, 0, 1, 2, and 3, that represents selling no homes. So what's the probability that this realtor sells no homes next month? 30%. So all you have to do is look at the 0, 0.30, 30%. Okay, C. What's the probability the realtor sells at most, here's the hard part. Think about what that means, at most. What's the probability that this realtor at most sells 1 house in in the next month period? At most 1. Phrase that another way. Someone give me some words that mean the same as at most 1. 1 or less. 1 or less. At most 1. So how many numbers are you going to use to answer that question?
2.
2 numbers, and what are they?
1 and 0.
1 and 0, but what are the probabilities?
80%.
Not together, separate.
30 and 50.
30 and 50. That's how you're writing this down. You're writing down that you're using 0.30 plus 0.50 equals 0.80. That's the work I need to see, what numbers you're using on your homework and the quiz. All right, one more. D. What's the probability that the realtor sells at least 2 houses in a 1-month period? At least 2 houses. That's the same as something or more or something or less. At least 2 houses. Something or more. What or more? 2 or more. So how many numbers, how many probabilities are we going to use off that chart?
2.
2 of them. And what are the 2 of them?
15.
15 and 0.05. That's right. 0.15 and 0.5. So the answer is
20%.
20%. 0.20. You got to show me which numbers you use to answer it that represent. Now I'm going to throw a curve in. I want to make sure you're ready for the homework. What's the probability this realtor sells between 1 and 3 homes next month? What's the probability this realtor sells between 1 and 3 homes? How many probabilities are you using off that chart?
3.
3 of them. Because you got to include what numbers? 1, 2, and 3 between 1 and 3 homes. You got to include the 1, the 3, and anything between them. So you would add up the 50% plus the 15% plus the 5%, giving it 50, 60, was that 70% in that case. You get it? That's how you do the second part of your written assignment. Everybody got that? That's almost too easy. I can't imagine there's any questions. But please. No? Okay, let's go to the next. I wanna review factorial because look at our formula. Factorial, factorial, factorial. So let's review factorial. Help me out. 5 factorial. What numbers am I gonna use? 5 times 4. 3, 2, 1. Anything else? Times 0?
No.
No. Okay. So factorial means that you, whatever number it is, times itself times every number below it down to 1. So if this were 10 factorial, it would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This is why find your factorial key. If it's not on your, you can't use your phone during the quiz, can't use a phone calculator, so either have a regular calculator or get familiar with the calculator that's on the computer, because you can switch it to scientific, you can switch it to normal, and find that factorial key. Because it makes it a lot easier than sitting there going, okay, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120, equals 120. 5 factorial equals 120. And it takes time, especially if you have a bigger number. So find that factorial key. So there's that. So now I want to go to, we're going back to chapter 5, PowerPoint to slide 16. Right there. There's the formula, same as I have on the board. Here's the deal. When you're reading a binomial probability question, it's all about you identifying 3 numbers. The given probability in the question, which will be given to you as a percentage, turn it into a decimal, and wherever that P is, I see 2 P's in that formula. That's where that goes. Let me say it again. There's 3 numbers you gotta find in a binomial probability question. The easiest one is the percentage that's being given to you, the probability being given to you in the problem. So if I said, the problem says that blah, 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 79%, that P is gonna be 0.79. There's the P. Everybody hear that? Now, the problem's gonna say, there's N and X. N is always the bigger number, X is the smaller number. Let me start there. The 2 numbers are, in all of these binomial probability questions, it says stuff like the sample size is 6. What's the probability 2 out of those 6 do this? There's the 2 numbers, 6 and 2. The N is the 6, the X is the 2. Now let me just phrase it another way. I might say a survey rep says there's 79% of people are texting while they're driving and holding one hand behind their back. I don't know, I'm making things up now, but listen. 79%, it would be 0.79, that goes where the P is. If we went ahead and pulled over a random sample of 10 cars to see if they had a hand behind their back and they're texting, what's the probability 5 of them will meet that criteria? What are the 2 numbers? 10 and 5. Which one is N?
10.
Which one's X? You get it. That's it. That's all you gotta do with these problems. Identify the 3 numbers and put them where they are. If you can just place them and set it up so it looks like that with the numbers instead of the variables, that is most of the points on that quiz question. That is most of them right there. You don't even have to solve it. If you can just get it set up, show that you know which numbers belong where. That is most of the points. And on the written assignment, that 3rd problem is where you are taking the numbers out of the problem and setting it up, but then you're solving it on your homework. Just so you know, but then you're solving it. But it's all about setting it up is where most of the points are. All right, so now, here's our first example. So focus on the 3 numbers that are gonna go into the formula. Whoop, hey. Evans Electronics is concerned about low retention rate for employees. In recent years, management has seen turnover at 10%. Just a big pause there. I don't know. It's just a number came out of me. I'm just pausing. Okay. Of the hourly employees annually. Thus, for any hourly employee chosen at random, management estimates the probability to be 0.1. So they're just turning it into a decimal for you. Believe me, the problem on the quiz will not turn it into a decimal for you. You gotta say, oh, that's 10%, and you gotta turn it into 0.1. Oh, okay? Blah, blah, blah. Choosing 3 hourly employees at random, what's the probability that one of them will no longer be with the company in a year from now? I changed the words to suit the same thing though. All right, so ready? Let me get off this slide. There we go. Give me the P. What is going to be the P right here in this one? 10%, and then this P is going to be 0.10, 0.10 to the exponent of x. And this is 1 minus 0.10. So if this is 10%, what's going to be in the parentheses? 1 minus 10%. What's that going to be? What's 100% minus 10%? 90%, 0.90. So this is 0.10, this is 1 minus 0.10, which makes it 0.90, the opposite of 10%. So these are always going to be the opposite of each other. Now, what's our n? How many employees were chosen at random?
3.
3 is our n. 3 factorial, that means 3 times 2 times 1. Here's another n right here, a 3 in the parentheses. We're going to subtract x and then do a factorial. Then we multiply times this factorial. Where else do we have n? Right here, n minus x in this exponent right here. The difference between the two numbers is going to be the exponent. So there's the 3 places where the n is. 1, 2, 3. What's our x in this problem? 1. It said, what's the probability that 1 out of those 3 will no longer be with the company? It didn't say 1 or less. It didn't say 1 or more. It said 1. Now think about it. The sample has 3. So how many different outcomes could we have? We could have 1 no longer being with us. We could have 2 out of the 3 no longer being with us. We could have 3 out of the 3 no longer being with us. And don't forget, we could have 0 out of 3. So there are 4 different possibility outcomes there. This question was asking about one of those 4 only. What's the probability that 1 out of the 3 will no longer be there? Don't mix it up with the question, what's the probability that 1 or less are no longer there? So now you got to do this for 1, and now you got to do this all over again, but make that 0. Because 1 or less would be 1 and 0, and you add the 2 outcomes, the 2 results. Let me say this one, right? What's the probability there'll be 1 or more out of those 3 employees no longer with us? What numbers are included now? 1, what else? 2, 3. I'd have to do this 3 times. I'd have to make x of 1 do everything, make x of 2 do everything, make x of 3 do everything. And x is in 4 places here. So I'd have to do this equation 4 times. Trust me, on the quiz, odds are I'm not going to say what's the probability of 1 or more or 1 or less. And I also want to point out, if I did say 1 or more, and you go, oh my God, I'm going to have to do this equation 3 times. I got to do it for 1, 2, and 3. Well, instead, say to yourself, wait a minute, I could do this equation for 0 and subtract it from 100%, and that would be 1, 2, and 3. Everybody hear what I just said? You could do it for the opposite of what's being asked for, which would only be 1 equation then, which is 0, because I'm asking for 1 or more, 1, 2, and 3. I don't want to do that 3 times. So the opposite of 1 or more would be 0. I make x is 0, do this 1 time, whatever the result is, let's say it's 10%, I then subtract it from 100%. My answer is 90%, because I only had to do it once that way. So that is the key to these binomials. Look at it and say, wait a minute, is he really asking me on this quiz that's timed to do this equation 4 times? Or say to yourself, wait, maybe if I do the opposite, which I only have to do it once then, and then subtract from 100%, I could find what he's asking for. All right, so that's the trick to binomial. You've got to pick those 3 numbers. I want to do enough. Here, before we show the calculation, I want to find another one. I want you to tell me what those 3 numbers are. And I'm going to kind of read it with no hesitation this time. I got to figure out how to get this up here. I got one out of the book. I'm going to page 178. Whoop, whoop. Boom. Let's see if I can get this full size. Let's see if I make it bigger. I don't know how to make it bigger. Can you guys see the far left, example 5.8? Can you guys see it back there, everybody? Over here? Okay. Let's look at it. I can't see it. Here's a perfect example of a binomial question. In the United States, about 30% of adults have 4-year college degrees. Blah, blah, blah. Suppose 5 adults are chosen at random. What's the probability that none of the adults have a college degree? Stop there. All right, let's start with, what's my P?
30%.
What's that? I forgot what it said, actually. Yeah, 30%. So change it to a decimal for me. Point 0.30. There's 30%. There's my P. What is my N?
5.
5. Very good. Because the sentence said we chose 5 adults at random. 5 adults selected at random, right there. So 5 is my N, and then A asked about how many? 0. What's the probability that we pick out of the random 5 that one of them, 0, have, what does it say? 0 adult have a college degree. So we would just do this with a 0 there, a 5 there, and 0.30 there. What's in the parentheses here? If this is 0.30, what's this 1 minus 0.30? 0.70, that's right, there you go. Up here, this would be 5 minus 0, which is 5. This would be 0. What is anything to the power of 0? We should have reviewed that. I forgot about that. Hang on. Any number to the power of 0. 1. Let me repeat that, because that's probably coming up and I forgot all about it. If that exponent is 0, if x is a 0 like it is in this case, this turns out to be a 1. Because this doesn't matter what the p is. Any number to the probability of 0 equals 1. It's been a long time. Is that true? Is that true? Any math majors here? Any math people? That's true, right? Yeah? You're the only one that knows. It's just you and me. We're alone here, so if we're wrong, I'm blaming you. Okay. All right. Let's look at B. What's the probability no more than 2 of the adults have a college degree? No more than 2 of the adults. Change that for me to 2 or what? 2 or less. No more than 2 means 2 or less. So there's 2. Wait. What's our P? What's our P in this question? Still 0.30. Didn't change. We're still talking about the 30% of U.S. adults having college degrees. Okay, what's the N in this one? What's N?
5.
Still 5. It hasn't changed. We still have a random 5. But the question changed. It says, what's the probability there's no more than 2, which we established means 2 or less. So that means we got to do this for 2, for 1, and then we got to do it again for 0 and add them all together. Or what would we have to do to find the opposite for 2 or less? What numbers would we do?
Could we do it for 3?
We would have to do it for 3, 4, 5. So no matter which way we go, we got to do this 3 times, right? So we're going to use Excel. That's what I'd say. I don't know. The answer's on the next page, how many times they do it. They're saying, look, for A, we already did it for 0. Then they did it down here for 1, and they did it for 2. And now they're adding all 3 of those results together. So 0.30, 0.36, and what was the first one? 0.16, almost 17. So you add all 3 of those, 0.17, 0.36, 0.30, 0.8370 is the probability of 2 or less out of the 5 randomly selected adults having degrees. Okay, I think you're getting it. I think you're seeing how to do it manually, now how to set it up at least, and how many times you got to do this equation if you have to do it manually based on the answer. Because this equation only does one number at a time. Doesn't do some number or less, doesn't do some number or more. You got to do every number involved. It does one number at a time. So now, let's look at one of the calculations being calculated. Let's look at the one that's in the book here. Oh, are you gonna have time for ironing class? Okay, so we put the numbers in. The first one is 3 factorial. 3 times 2 times 1 is 6. The next one is 1 factorial and 3 minus 1 factorial. So that'd be 2 times 3 minus 1 is 2. 2 factorial is 2. 1 factorial is 1, so 2 times 1 is a 2, right? So 6 over 2 is our left side. What's 6 divided by 2? There's 3 right there. So there's the part with the division. That whole thing turned into 3. 6 divided by 2. Now, 10% to the power of 1, well, that's going to be 10%. Anything to the exponent of 1 is itself, right? So that'd be 10%. Now, 0.9 squared, because we had 3 minus 1 is a 2. So 0.9, the opposite of 10%, which is 90%, squared, 0.81. So now we multiply our 3 results all across, because we have 3 parts here. 3 times 0.1 times 0.81. There's about a 24% chance that out of those 3 employees we chose at random, one of them will no longer be here in a year because we usually have 10% turnover. So there's about a 24% chance that one of the three won't be here. Does everybody see how the breakdown is? You break it down into the three parts. Do the fraction, the whole setup with the numerator and denominator first, then do the middle proportion, the probability in the middle, that's to an exponent, and then the right-hand one minus the probability to an exponent, n minus x. So do those three parts, and that's how you solve it. Now, if I had to do this again, I'd change x to another number, solve it again, and then I'd end up adding them together. Just like on page 179 that we just looked at, they're adding three of them together for that second question we did. Okay, any questions before we go to Excel?
Do you want the answer to stay as a decimal?
You can leave it in decimal or change it into a percentage, it's up to you.
And do you want us to round the answer or keep it as?
You can, if you decide to round the answer, at least go 2 digits to the right of the decimal, as long as you round correctly. All right, so rounding's fine, as long as you at least leave 2 digits to the right of the decimal and do correct rounding.
So let's say it said, what is the probability that like 2 instead of the 1?
Yeah.
So we make 2 of them basically?
If it said 2 or less, you would have to do it for 2, 1, and 0. You have to do it 3 times. But if it said, what's the probability of just 2? You only have to do it once for the number 2 only for x. This one said, what's the probability of 1? It didn't say 1 or less, it didn't say 1 or more. So that's why we only did it once for just the number 1. Now, if this would have said 1 or less, we'd have to do this again for 0, making x a 0, solve it, and then add the 2 probabilities together. All right, here's the hardest part. This was hard, this was hard, but here's, some people find this hard too. Okay, the binomial, or the Excel function word to find the binomial distribution probability is binomdist. This also has a dot between the binom and the dist. They're the exact same one. You can use the dot, you can not use the dot, that's up to you. The first number in the parentheses is the x. X is the first number. Let me put that up here. The second number is the n. The n. The third number is your probability. And the fourth number is either a 1 or a 0. A lot of people will use the word true or false. I always use 1 or 0. They mean the exact same thing, they do the exact same thing. It's just easier to use a 1 or 0 instead of typing out the word true or false. So 1 or 0. Okay, now, what do they mean here? Let's start with that question. Our company has 10% turnover. Remember the electronics, Evans Electronics, 10% turnover usually. We randomly selected 3 employees. What's the probability 1 will no longer be with us? Okay, here's our 3 numbers. 0.10 is the P, so 0.10. X, I asked, what's the probability that 1 will no longer be with us? So that's a 1. N, I said we randomly selected 3 employees, so that's a 3. Now, whether you use a 1 or a 0 at the end is whether the question is asking for exactly 1 out of 3 employees, or is it saying 1 or more, or 1 or less, or at most 1. If it's including more than just 1 number being asked for, you're going to have a 1 on the end. Because what the 1 does, it tells Excel, I want you to find the probability for 1 or less. So I want you to find the probability for 1, and then I also want you to find the probability for 0. And I want you, Excel, to add those together all in one function. By putting a 1 on the end, you're telling Excel to do 1 or less and add them together. By putting a 0 on the end, you're telling Excel you want the probability for just X, just 1. And you only want it done 1 time. Now, what would I use at the end, and what would I use for X at the beginning? These 2 numbers here, because there's 3 employees at random. We usually have 10% turnover, but if I said, what's the probability 2 or less will no longer be with us? What goes here at the front? What's the probability 2 or less will no longer be with us? What goes in the front?
0.
No. 2. 2 or less. What goes on the end, a 1 or a 0?
1.
A 1. By giving a 1 here, you're telling Excel, I want you to find the probability for 2, and for 1, and for 0, and add them together, 2 or less. That's what putting a 1 on the end does. You ready? 3 random chosen employees. We usually have 10% turnover. I want to find the probability that all 3 will no longer be with us at the end of 12 months. What's going to be this first number?
3.
I can't hear you. 3, that's right. Because I said, what's the probability that all 3 will no longer be with us? The sample size n doesn't change. There's still 3 employees. We still have 10% turnover. What's the number at the end when I said, what's the probability that all 3 will no longer be with us? What's the number at the end?
1.
That's right, 0. Because I'm asking for exactly 3. I'm not saying 3 or less. So that's what's going on here. Equals binomial distribution 1, 3, 0.1, 0. That's finding the probability of just 1 employee out of the 3 no longer be with us. Look at the answer, 0.243. And remember on the PowerPoint, it was 0.243. Okay, so now, let's go to that next question. You ready? I said, tell me what to change if I said, what's the probability out of these 3 employees, and we usually have 10% turnover, what's the probability that 1 or less will no longer be with us? What has to change up there? 1 or less.
The 0 needs to change to a 1.
The far right-hand number 0 has to change to a 1 to tell Excel you want the probability for 1 or less. There it is. So now it's going to include the probability for 1, which was 0.24, plus the probability for 0, which is going to be another, who knows. So it should be bigger than 0.24, obviously. The answer, oh, look at that. The probability of 0 was huge. So the probability of 0 and the probability of 1 out of 3 employees no longer being with us, when we usually have 10% turnover, is 97% chance. Are you ready for this? This is the moment. God, this could be too soon. I almost feel it. I can feel the energy off here. This could be too soon. You ready? What if I were asking, what's the probability that more than 1 employee will no longer be with us? Let me repeat that. What's the probability that more than 1 employee will no longer be with us? What do I have to do to this Excel equation? Go.
You have to do 1 minus the
Okay,
equation.
this is the tough part. He's absolutely correct. Here's the hard part. If you have a question that's asking for more on a binomial distribution, a binomial probability, you gotta put 1 minus in front of this whole equation, but the hard part is, what's in the parentheses has to be the opposite of what's being asked for. Now notice I didn't say, what's the probability of 1 or more? Because putting a 1 minus in front of the binomial won't be enough. Because the opposite of 1 or more would be 0 or less. I'd have to make that a 0 in the parentheses. Because this is the weird part about binomial. When we get to, after the quiz, there's a whole bunch of these problems where you don't have, it doesn't matter what number the first number is. If I said 3 or more, you put a 3. If I said more than 3, you put a 3. But with binomial, this is very touchy. If I said more than 1, you're putting a 1 there, because the opposite of more than 1 would be 1 or less. But if I said 1 or more, putting a 1 there wouldn't be the opposite. Because I'm saying 1 or more, the opposite would be 0 or less. So you'd have to put a 0 there. So now, here we go. I asked the question, what do I have to change to find the probability that more than 1, 2 or more of the 3 employees I randomly chosen no longer be with us? So all I gotta do for more than 1, 2 or more, is put a 1 minus in front. Now this should be the opposite of what we just got, which was 97%. So this should be around 3% or whatever. There it is, 2.8%. That makes sense. That's 2 or more, because in the parentheses is 1 or less. There's a 1 where the X would be. Now I want to change this. I want to find the probability for 1 or more now. I want to find the probability for 1 or more. But this is finding the probability for 2 or more. What has to change?
Put a 0.
Say it again.
You put a 0
Put a 0 where?
at the end.
Not the end. You had it. You had it though. Not the end. You gotta put a 0 for X, because the opposite of 1 or more would be 0 or less. You gotta have a 0 where that X is. You don't have to change the end, because 0 or less is just 0. You get the same answer whether you had a 0 or a 1 on the end. You didn't, so you don't have to change that, but you gotta change that first number. That first 1 has to go to a 0. So I'm asking now, what's the probability of 1 or more? I'm gonna change that to a 0. This will be 1 or more, because in the parentheses is 0 or less.
Does it still have the one minus in front of it?
And it still has the 1 minus, because I'm asking for 1 or more. So the 1 minus is in front, binomial distribution, 0, comma, 3, comma, 0.1, 0.1, 1. So it took the 24% for 1 and added whatever 3 would have been, which is another 3%. Add the 24 plus the 3, because that's for 1, that's for 1. What is this? 1 or more? 2. So what do you think the probability for 3 is? That all 3 out of 3, this is gonna be so low. Hang on a minute, I'm doing 3, I'm getting rid of the 1 minus, this will be 3 out of 3 employees that are randomly selected 3, all 3 are no longer with us. You ready? Well, that didn't make sense. It's because I forgot to change the 0 on there. This is saying that at least 3. Look at what I just did, that 3 or less will no longer be with us. It's saying the odds of 0 or 1 or 2 or 3 people no longer being with us out of randomly selected 3 is 100%, because yeah, nobody could leave or 1 could leave or through. I didn't put a 0 on the end. If I want just to know the probability of 3 on the nose, this should be, whoops. Now this is gonna be really low. It's 1/10 of 1%. That 3 out of 3 are no longer with us when usually we only have 10% turnover. Okay, we gotta do the in-class assignment. You ready? Get a piece of paper out, match it up with 3 people, talk about it while you're doing it this time. Not just do it and then talk. Talk while you're doing it. Turn around, include people behind you. Put your name on it. Here it is. How much time we have? We have time? We have time. I want you to take these 2 binomial distribution questions and set them both up using this equation. Do not solve either one of them. It's all about you setting up 2 problems using that equation. It's all about the setup. I want to see that equation. I want to see that equation using the correct numbers for all the variables though. That equation using the correct numbers. The first one says, according to a recent survey, 68% of all U.S. adults are Facebook users. Consider a sample of 50 randomly selected U.S. adults. What's the probability that exactly 38 are Facebook users? Notice I put the word exactly 38 because I don't want you to have to write multiple equations, just one equation. The next one says, it is reported that only 32% of Americans have confidence in U.S. banks. If 6 Americans are chosen at random, what's the probability that exactly 3 have confidence in U.S. banks? This is too easy. If everybody doesn't get 100 on this one, I'm going to be bummed. I don't know what else to say.